Okay, let's look at example 3.1 where you have a lever arm with a vertical force on it. So part A is you're supposed to find the moment about O. Okay, so let's look here at part A. If I can do this. Try this again. Okay, part A. Supposed to find the moment. So we have this lever arm, and there's a force down here of 100 pounds. And this is a distance in this direction of 24 inches, and we know this angle of 60 degrees. Okay, so what do we have? Moment is R cross F, right? But that's not what we're going to use, because the other thing is, is the magnitude of the moment is force times distance. So it's equal to 100 pounds and times the distance. Well, what distance? In this case, we're looking for the distance from here to there, the perpendicular distance to the force. Well, that distance is 24 times cosine of 60, in which case this moment ends up being, cosine of 60 is a half, so 24 ends up being 1200 inch pounds. So that is the answer for part 1. That is has a moment of 1200 inch pounds. And then for part A, sorry, for part B, it says a horizontal force at A which creates the same moment. So what we're saying is part B, we're going to rewrite this as having this same object. Sorry, this is probably a little too shallow. Instead, we have this same thing, but now we have a force off here, F of we don't know how much. This distance is still 24. This is still 60 degrees. So we want our moment is force times distance, and we know that that is, in this case, 1200 inch pounds, and that's equal to force times distance. Well, in this case, we know the distance. It's the vertical distance from here to there, which in this case is 24 times sine of 60. So when we solve this, force therefore is equal to 1200 inch pound over 24 sine 60 inches. The inches cancel, and the force is 57.7 pounds. So that's the answer for part B. Okay, let's scroll up a little bit. Part C. So the smallest force at A, which produces the same moment. So here we're looking at this point A here, right? So what force can we produce there? So we have moment is force times distance, and this is still the 1200 inch pounds. So what force could we do here? Well, if we have this object, we know this is 24 inches. To maximize the moment, you need to go perpendicular to that, right? Because then you have your, 1200 inch pound is equal to your force, which is what we're looking for, times the minimum distance, which is going to be 24. So therefore, this is inches. So your force is going to be 1200 divided by 24, which is 50 pounds, if you do your force perpendicular in that direction. So that is part C. Part B. Okay, part D, the location for a 240-pound vertical force to produce the same moment. Okay, so what do we have? So what it's saying is we have still this same thing here. We're going to a vertical force, boom, of 240 pounds. We don't know where we're going to put it here. How far we're going to put it. This is still at 60 degrees though. And we want the same moment. So again, yet again, moment is force times distance. So the 1200 inch pounds is the force, which is 240 pounds, times the distance. Well, the distance is going to be this x value, but still we're only looking at the distance from here to here, the perpendicular distance to that force. So that is going to be x times cosine of 60. So in this case, x is equal to 10 inches. So this needs to be pushed 10 inches up, 10 inches in order to have the same moment. Okay, the last question is, are any of these forces, so whether any of the forces from B, C, and D are equivalent to the original force. Okay, so let's look at, we're talking about this one right here. What does it take for a force to be equivalent? Well, for a force to be equivalent, you have to have the same tendency to translate and the same tendency to rotate. Well, here, we're looking at A. This has a certain moment, right? It has 1,200 inch-pounds inclination to rotate. This one has, right in there, the same moment, right? And this one has the same moment, and this one has the same moment. These all have the same moment because, quite frankly, that's what was asked, given the same moment. So these all have 1,200 inch-pounds moment, or that much tendency to rotate about point O. But now the question is, do they have the same tendency to translate? So this one, part A, there's 100 pounds trying to push down. That's the only thing it has. So 100 pounds trying to push down. In this case, you end up with the force is 57 pounds. So this one has an inclination of 57 pounds, 57.7 pounds to translate to the right, which is not the same as 100 pounds translating down. And then part C, right, has 50 pounds going down and to the right, and part D it has 240 pounds going down. So these are definitely not equivalent systems. Although they have the same moments, in order for a system to be equivalent, it has to have the same tendency to translate and the same tendency to rotate.